Now we are done with the series and we now know how to calculate the geometric series as well as the arithmetic series. Now, how do you find the Tn, the general term, when you are given the sum of the nth term of that specific sequence series? Okay, so how do we do that? This is the equation. Tn is always equal to Sn minus 1. Okay, for of course n greater or equal to 2, which means your n values or the number of terms which are in that specific series, there should be 2. Okay, so this is how we can calculate our Tn value if we are given the sum of the nth values. Okay, well, the sum of the terms which are in that specific series. But now we also need to understand that your term number 1 is equal to the first term in the series, okay, on the sum of the series equation. So this will be able to be made to understand, you'll be able to understand this better if I make an example. Okay, so let's say that we are given the sum of the first n terms of a certain sequence. The sum of the first n terms of a certain sequence is given by, let's say it's Sn is equal to 2n squared plus 9n. Okay, now question 1.1, we can say that determine the first two terms of the sequence. Okay, now number 1.2, maybe we can say that determine the 12th term. Okay, it's just for fun, just for you to understand it, of the sequence. So how do you do that when we are given our Sn, which is Sn in this instance is given as 2n plus 9. This is easy and straightforward again, because we know that our term number 1 is always equal to S number 1. And of course, we know that Sn is equal to Sn minus 1. That's how we can be able to calculate the Tn, or the general term. So now let's look at the solution to this problem which we have at this point. So the solution is quite easy and straightforward. How do we do this? How can we maneuver around this? So the first thing is to understand that, okay, we are given that our Sn is equal to 2n squared plus 9n, and we know that T1 is equal to S1. So it's easy, which means we can calculate our S1 there. So our S1 in this instance is just going to be equal to, where there is n, we are replacing with that 1 plus 9 times 1. So 2 times 1 is 2 plus 9, that's going to be equal to 11, which means that our S1 is equal to 11. But in order for us to get T2, we know that Tn is equal to Sn minus 1. So if we want T2, this will be S2 minus S of 2 minus 1. Okay, interesting stuff. Okay, because the n value has changed. Now we want the second term, because that's the term which is going to be the second term which we want over there. Okay, so that will be S2 minus 1. So then therefore term number 2 is going to be equal to S number 2 minus your S of 1. Okay, so what is S2? S2 will be equal to, in that equation which we are given of Sn, which is equal to 2n squared plus 9, and now we want S number 2, so that will be 2 times 2 squared plus 9 times 2. Okay, we substitute there, plus minus our S1, we have calculated it, and our S1 is equal to 11. Then after that you use our calculator, then your S2 will be equal to let's calculate 2 times 2 squared plus 9 minus that, then we get our answer there to be 15. Okay, so then therefore our two terms T1 is equal to 11, our term number 2 is equal to 15. Okay, easy stuff. Okay, again, I'm gonna say this again. This is the equation which is important. If you understand this equation, this is important, and this will get you the answers which you want. Just understanding that your Tn is always equal to Sn minus 1. Now they say calculate the 12th term again, which means this is easy. In order for us to get the 12th term, we need to understand that the 12th term, we need to understand and get the S11. Okay, so again, we start by writing our new equation that Tn is always equal to Sn, okay, minus Sn minus 1. Now we want t number 12. T number 12 will be equal to s number 12 minus s of 12 minus 1. Lekker. So now we are just substituting in that original equation which we are having, okay? S number 12, which means that in that original equation, Sn is equal to 2n squared plus 9n. On the position of n, we are now replacing that n with 12. So that will be 2 times 12 squared plus 9 times 12, okay, minus, now we are on this. We know that 12 minus 1 is the same as 11. So now we want sum of the first 11 terms there. That would be minus, then we put brackets there. That would be 2 times 11 squared plus 9 times 11. Again, we use our operators, then we can get the term number 12. Then, of course, using your calculators there, I am also using my Casio calculator. Then I'm also getting the sum or the term number 12 to be equal to 55. Of course, it's true, and you are good to go. Okay, then if you were bored, you wanted to find this term number 12 in a long method, since you already know your T1 and T2, you can see that this is 11, this is 15. Perhaps if you also knew term number 3, again, you're going to do it in the long method and calculate your Tn. Then after you get your Tn, then now you can just substitute your T to the T, and you substitute the position of n with 12. So that can get the value of the term which is situated in that specific position. But that's a long method. But always, when you are given your Sn or the sum of the first term, you can be able to calculate our Tn or our general term or the terms of a sequence by saying that Tn is equal to Sn minus Sn minus 1. If they say that calculate what is the term number 200, when you just say term 200 is equal to S of 200 minus S of 200 minus 1. This will be 1999. So that 1199. And you now just substitute in that equation which you are given for the Sn. Then you can get your term which you want. Dango means thank you.